be starting performance task number 2. Alright, so here we're going to be determining whether these compounds are ionic or molecular. So for calcium acetate, this substance is ionic due to the electron donations coming from the calcium atom. It's donating a few electrons over to the acetate, which will make a whole lot of sense later on, because I'll be showing the actual formula for it. And moving on, we have, I'm just going to read it as it is right now. We have Fe2 and SO4 3. Alright, and that is ionic. And once again, this is ionic due to this having a metal, first of all, and that it is also donating electrons to be able to neutralize the compound as a whole. And now we're going to be moving on to iron 2 sulfate, which is molecular. Since this compound is being held together by covalent bonds, there's no giving or stealing. There's mostly just sharing between the electrons, or between the atoms in the compound, which when they share electrons. And now I'm going to move over to SO3. And this compound is held together by no metals, and it is held together totally by a covalent bond. So I would say that the bond that is holding SO3 together is molecular. Now I'm going to be moving on to why these formulas are called that way. Oh wait, not why they're called that way. Why their formula is what it is. And so calcium acetate's formula is Ca C3H3O2 2. And I mostly followed the IUAPC rules, and I noticed that this is calcium, and this was acetate in the IUAPC rules. So I connected the calcium together with the acetate, or it was originally called acetic acid, but I don't think we would be calling it calcium acetic acid. So I just plug them together, calcium and the acetic acid, and I got calcium acetate. Now I'm going to be moving on to iron 2 fluoride. Iron 2 fluoride, once again, I'm going to be following the IUAPC rules. It's called iron 2 fluoride because the iron ion is oxidized by 2, and it is also attached to 2 fluoride ions. And just looking at iron fluoride, I was able to just immediately be able to write down the formula for this, because I pulled down iron, which is Fe, and then fluoride, which has ide, meaning there's 2. So it would be FeF2. Now I'm going to be moving on to substance names. Alright, yes, substance names. And it is just the names of the substances represented by the formula. So we have Fe2SO4 3. This is going to be iron 3 sulfate. And first I picked up the iron from the Fe, which is iron, and the sulfate, which I grabbed from the IUAPC, which is SO4. So I can, in order to fully neutralize the formula, iron would have to have a oxidization number of +3, so that would be able to donate the electrons over to the sulfate ion. Now I'm moving over to SO3. And this one was a whole lot more straightforward, because I was able to just pull the S, which is sulfur, the sulfur atom, and the O3. And it's called trioxide because there is 3, and it would have in most formulas which would have 3 of an atom will end in the suffix, we'll begin with the suffix tri, so it would be like trisulfide if it was something like another atom mixed with 3 sulfur atoms. Now I'm going to be moving on to the fun math, which is the molar mass of CrSO4 2. So I just grabbed the molar mass for Cr, which is 51.996 grams per mole. The S atoms, which there are 2 of because of this multiplying everything in here. So now we would just multiply 32.065 grams per mole times 2. And then I'm going to move down to the oxygen. We have 8 oxygen because 2 times 4 is 8, so there would be 8 little oxygen atoms right there. And that would be 15.999 times 8. And in total, we would have the total molar mass of CrSO4 would be 244.121 grams per mole. Now I'm going to be moving over to the mass of calcium acetate in 0.65 grams per mole. So first I found the molar mass of calcium acetate, which is 158.17 grams per mole. And in order to find I'm pretty sure this was searching for the mass present in 0.65 mole. So we would multiply the grams per, we multiply the molar mass times the amount of moles that we're trying to, the amount of moles present, and we would receive 102.71 grams. This is the amount of calcium acetate that will be present in 0.65 mole. And now I'm going to be moving on to even more math. Alright, how many liters, this is the question, how many liters of SO3 gas will be present at STP, that is standard temperature and pressure? So first I grabbed the molar mass, which is the molar mass of SO3, which is 80.06 grams per mole. Then I would multiply that by the given mass in order to get the mole, which is 15.7 grams times 80.06 grams per mole, and we would then receive 0.196 mole. And then to go even further to get the how many liters are present, I move over to the molar volume of mass at standard temperature pressure, which is for all gases, which will be 22.4 liters per mole. And I would then plug that in with the mole I received previously, and it would be 22.4 liters per mole times 0.16 mole, and then I would get 4.39 liters of SO3 gas in total, present in 15.7 grams of gas. Now this is a really fun one. I thought this one was pretty fun. And I just had a little more iron ions. And we were just figuring out which contains more ions. 5.18 times 10 to the 21st particles of the, just gonna grab the name, iron 3 sulfate compared to 180.5 grams of iron 2 fluoride. First I'm going to start off with the iron 3, and this one was pretty easy because there are 2 total iron ions in this formula, and we would just multiply 2 times 5.18 times 10 to the 21st, and then from that number we would receive 1.036 times 10 to the 22nd iron ions present in this one formula. Now I'm going to move over to this one. And 180.5 grams of iron 2 fluoride. First I grabbed the molar mass, which was 93.85 grams per mole. Then I divided that by the mass I received to get the moles, which is 1.924 mole. And then I plugged that in with Avogadro's number, and I received 1.158 times 10 to the 24th iron ions. So we can see that the 180.5 grams of iron 3 fluoride has more iron ions present than 5 times 5.18 times 10 to the 21st particles of iron 3. Wait, oh, I'm sorry, iron 2, no, yeah, iron 3 sulfate. Yes, so this one would have more. All right, thank you.